Alright, this is kind of like what I tried to show you in class, that if the time changes, the force changes. So we have two cars. They're both the same mass of 1400. They're both going 20. If they crash into a barrier, the change in velocity is going to be 20 to 0, which is 20. The change is 20. So find the average force, and they give us a time. So let's do A first. Whoops. Let's do A first. And so here's A. It's going to be force times time equals mass times change in velocity. And we want to know force. So force is the question mark. A has a time of 1.5 seconds. The mass is, they're both the same, of 14 kilograms. The change in velocity is 20. Why? Because it goes from 20 to 0. How do you get F all by itself? We'll divide this out of both sides. Bye-bye to that side, hello to that side. So I gotta get the calculator fired up here. 1400 multiplied by 20, hit enter, divide by 1.5. I'm gonna get a force of like 18,666, which I'm gonna turn into 19,000-ish newtons. I rounded. Now let's do B. My time changed on B, which makes sense. Change in velocity. Alright, so basically it's force equals mass, which is 1400 kilograms. That bad boy changed 20 meters per second as I brought it to a stop, and now we brought it to a stop in a tenth of a second. And again, this is kind of stuff we did in class, sort of, kind of. 1400 multiplied by 20, hit enter, divide by your 0.1. You should get a huge number now, right? 280,000 newtons. That's crazy big. Yes, if you compare the two, it's a lot bigger. As the time goes down, the force goes up, and we just proved it with math. Bye-bye.